Hello, everyone, and happy Friday. Welcome back for another webinar. This week, a guest presentation. My name is Damien, and I work with all of our manufacturer partners, and I will be in the background moderating today's session. Continual advancements in technology across the manufacturing sector, to say the least, have enabled product designers and manufacturers to really reach new levels of innovation in their processes and ultimately their end product, which subsequently provides a really great deal of options for the end client. Today, we're taking a bit of a dive into the world of manufacturing of modern site furnishings, which is being brought to us by David Traphagen of Anova Furnishings. David's going to be talking about and showing us some aspects of design and manufacturing processes that are perhaps less considered in the grand scheme of a landscape architect's project life cycle, but hopefully you'll learn about some different design philosophies, manufacturing methods, and technologies here today. Before I do hand over the mic to David, got our usual housekeeping items. We love to see your questions come through, and I know our presenters love hearing those and answering them. So when you do have a question, don't forget to pop them into the Q&A question box, which can be accessed by clicking the Q&A button on your screens. We do occasionally see some come through the chat line, but if you can just remember to put them in the Q&A box instead, that would be much appreciated. And I will be engaging with David as quickly as I can as those questions come through. So when you ask about a specific slide, we hopefully won't jump around too much. We will, of course, have time for questions at the end as well, but don't let that stop you from getting in early. So from here, I would like to hand over to David to introduce himself and get us underway. Thanks, David.
Appreciate it. Thanks, Damon. As you said, so my name is David Traphagen, one of the regional sales managers with Anova Furnishings, based in Chicago. As alluded to, so we're going to be talking about some manufacturing today. So some additional kind of housekeeping items really quickly, and just a little bit about us, I guess. So Anova Furnishings, if you aren't familiar with us, we're a site furnishings manufacturer. We've been in business for about 50 years. So next month is our 50th anniversary, actually. We're headquartered in St. Louis, and then we have two manufacturing facilities here in the U.S. Both one in Winona, Minnesota, which is about 2 hours south of the Twin Cities, and then also a facility in St. Louis, which is where our headquarters is. So again, just a little bit about us. I don't know how familiar you are with us, but one housekeeping item is, so part of the distance learning requirements are that we do need to issue a quiz to attendees post presentation. There's 10 questions. I will very, very clearly call out which the questions are and the answers. So just pay attention. If you need, for some reason, you miss a question or you miss the answer, whatever the case is, feel free to throw that into the Q&A as well. I've done that plenty of times as well. I'm happy to either go back or answer it or whatever the case is. So at the end of the presentation, there's a quick QR code, which you can scan with your cell phone. Just open up the camera and you can, it'll automatically scan it. We can also send out direct links at the end if that QR code thing doesn't work. But if you have any issues with that, let us know. What are we going to cover today? So again, manufacturing, but really there's three main topics that we're going to look at today. So we've got this idea of really the manufacturing processes involved. So when I build these presentations, I like to kind of give people a baseline of information regarding what it is that we're going to be talking about. So a standard set of definitions to kind of get us moving. Then this concept that's called lean manufacturing. So what is it? Often you hear a buzzword of sustainability. So what does sustainability from look like on a manufacturing environment? And lean manufacturing is a great segue into that conversation. So we'll look at that a little bit. And then finally, really our last section is intended to be a little bit of like a presentation mode sort of virtual tour of a manufacturing facility. So we're going to kind of walk through in order, in chronological order, of how things would actually be made, and kind of give you an idea of what that process will look like. So that's what we're going to be looking at today. So without further ado, here we go. So manufacturing processes. What are some of the processes that are used in creating furnishings? So question 1 and question 2 here. But really, the first thing to start with is this idea of additive versus subtractive manufacturing. So additive manufacturing, which is often referred to as kind of the nomenclature of 3D printing. So 3D printing and additive manufacturing are basically the same thing. But additive is this concept of taking a small medium of material and combining it into larger and larger pieces to create whatever kind of object that you're creating. And I've got a chart on the next slide that kind of illustrates that. Subtractive manufacturing is the exact opposite of that. So you're starting with a big piece of material. You're subtracting away material using a variety of different methods to create then a product or a piece that you're looking for in the end. So question 1 is, it's a true-false question. What are the two manufacturing methods? Is it additive and subtractive? The answer is true. And then question 2 is related to additive manufacturing. Question 2 is related to subtractive manufacturing, and it's this definition here of subtractive manufacturing is the process by which 3D objects are constructed by successfully cutting away material from a solid block of material. So really, if you have subtractive manufacturing is a process by which 3D, if you get that far, you'll have the answer to the question. So there's question 1 and 2. So on this slide, again, really good illustration of additive and subtractive manufacturing. So the top one here is talking about subtractive manufacturing. So on the left-hand side, we have our big block of material. In the next on the is basically our machine that's going to be subtracting away, cutting away, whatever the case is, that material to create our 3D object. So you're starting with a big block of material, you're removing material to create your object, and then you have this waste that you do something with. You could either recycle it or whatever. So additive manufacturing is really the reverse of that. So you're starting with this small material. You're building it up layer by layer by layer to create the same type of object. And then the waste in the end is relatively small. So this is really the two concepts as you kind of create different shapes within a manufacturing environment. So here's question 3, but really it's talking about the additive manufacturing process. So what's another name for additive manufacturing? And the answer is 3D printing. So specifically as it relates to site furnishings, a lot of site furnishings are made of metal. So you can actually 3D print metal. It's a slightly different medium that you start with. So you start with really metal dust. And then it's a slightly different filament head that you're using to actually create and build up the layers. So anytime you're working with a metal 3D printing application, again, starting with a powder bed of some type of a metal, whatever the case is, and then you're using some type of a heat source, electron beam, lasers, all sorts of different various heating methods to slowly build up and melt the dust layer by layer and to build up your object. And I've got a short video on the next slide, but there are a variety of different methods within 3D printing, and it's really talking about what's the material that you're using to begin with, and then what's also the heat source that you're using to melt. That kind of is the differentiation between these various methods in here. So yeah, just giving you an idea of how the 3D printing process could work. Again, using that metal as the medium. So obviously there are other methods if you're not working with metal that you want to 3D print. And this again is where some of the differentiation comes into play in types of the types of 3D printers that are being used. But you could do a variety of different starting mediums or starting materials. You could start with some type of a polymer. You could build in ceramics. Again, you could do metals, as we said. Depending on how that is, metal, you obviously have to heat things up. If you're working with more of this kind of clay material, this is really kind of an extruded method, and you're building it up layer by layer there. So again, depending on how you do or what you're starting with or what you're trying to create in the end will determine what type of 3D printer and what application method really this filament head is going to be using, whether it's heat or building it up layer by layer, that sort of thing. So we can move into then this idea of subtractive manufacturing. So a common term that people hear when they're thinking about site furnishings or manufacturing of site furnishings is this concept of a CNC machine. So a CNC is really, it's a subset of a bunch of different types of machines, but really it's a mechanical method of cutting away material. So you're using tools to cut around a solid piece of material on either 2 or 3 axes. So depending on how complex the object it is that you're trying to create will determine how many accesses that you need. Do you need a just horizontal and vertical component, or then do you also need a component where the axis can come in from the side? As you add in more accesses to the machine, they get more and more expensive. But you can also now create some more unique shapes depending on how many accesses you can pivot your tools onto. So, but big call out with CNC is that it's using tools and it's physically cutting away that material. The example I always give is it's similar to like a drill bit. It's sort of in that world, but it's similar to like a drill bit, and it's kind of cutting away very, very small layers at a time to create your shape. The other one that you hear frequently is this idea of a laser cutter. So a laser cutter is really a more advanced and a faster version of a CNC. So instead of using a mechanical tool as its cutting method, it's using a laser. So the laser works obviously to melt the material at a very, very fine way to create whatever it is that the shape that you're trying to create. So often the picture here, they're cutting out some words out of a piece of sheet metal of some kind. So the laser will cut all this out. Now the big thing to note, I guess, is that this is not going to cut away all of the material inside of here. It's going to cut away the outline of whatever it is that you're trying to create. So as soon as this comes out of the laser cutter, it has to be knocked out. All of those different pieces have to be knocked out to kind of get the shape that you're trying to create within this piece of sheet metal. So a variety of different lasers can be used. There's not just one laser. There's a variety of different fuels that would be what's powering an actual laser. I won't necessarily get into that piece, but there are many, many different types of lasers. Some have, benefits and disadvantages versus the other. If that's something that's ever interesting to you to kind of dive into that, just feel free to pull me aside and we could chat through it. So we've got this idea of additive versus subtractive manufacturing. Now we kind of move into this idea of what's called transformative manufacturing. And this is also question 4. So what are the 3 transformative manufacturing topics? And you have casting, forming, and joining, those 3. So we'll start off with this idea of casting, also something that's become a lot more prevalent and common in the site furnishings world. But really casting is starting with a substrate of liquid, and a lot of times metal, liquid metal, and pouring it into a mold of some kind to create unique shapes. So casting is a process that allows you to create things that might otherwise be either impossible or extremely challenging to create using other transformative methods, whether that's welding pieces together or more forming methods, things like that. So it becomes a solid piece in the end, as opposed to having to again weld pieces together or mechanically hold things together using nuts, bolts, hardware, things of that nature. So a couple kind of pieces to understand when you're talking about casting. There are a few terms to understand. So the mold itself that's the shape that you're trying to create. So if you're trying to, in the site furnishings world, if you're trying to create the arm and leg of a bench, that is the mold shape that you're trying to create. It's the negative space that you pour the metal into to create the shape. Dimensional tolerance and near net casting are related. Dimensional tolerance is really what's the acceptable size of the final product in the end. It's not a perfect science all the time. This is a very manual process, which is why sometimes casting, you'll see increases the cost of your site furnishings if you're seeing a lot of casting pieces. It's a very manual, expensive process to go through. So what is the acceptable tolerance that's required? It has to be within 1 to 2 millimeters, or whatever the measurement might be, and that's your dimensional tolerance. It could be anything, but so that's what that's talking about. Near net casting is kind of the continuation of dimensional tolerance. It essentially means that it needs to be as perfect as possible every single time. Now you would think that that's pretty much what you want to achieve every time when you're casting, but near net casting is very expensive. You often have a lot of waste because you have to throw out stuff that does not meet the dimensional tolerance of essentially perfection. So have to get rid of those. It's also different mold creation that you have to use in that near net casting. It's a different process, but again, adding cost if you're going to near net. And then surface finishing. So depending on the type of mold cast that you're using, you can create some different surface finishes. So you can have kind of a granular or bumpy or a rough surface if you're using a sand casting, which is very common. And depending on the type of sand, whether it's a rough or a coarse type sand or a much, much finer sand, will determine what that finish of the cast ends up being. So this is question 5 here, but we're talking about casting. And essentially what we're doing here is creating, if we look at the diagram here on the right, this orange object is what's trying to be created here in this case. So you have your essentially half of the shape that you put into a box, and you pack sand around that half of the shape. Once you have that all packed in, you can flip it over, which is diagram 2 here. And then you would put the second half of the box in, put in these little pins here to allow you, if you look down here, those are the holes where you actually pour the liquid metal into further down. And then you put the second half of the shape in the second half of the casting, or the second box here. And then you pack sand around it again. So once all your sand is packed in there, then you remove all of that stuff. So you remove the mold shape. Now you're left with this negative void. So you put everything back together, you put the boxes back together, and now you have this space where you can actually pour your metal. So you pour your metal in, and you've got your shape. It'll fill up the void where the sand is, or where the sand is not. The call out is that once you actually are done with your casting and it cools down, these vents and these holes where all this metal came in are still filled with metal. So there requires some, that surface finishing, that a little bit of refinement. You have to remove all of that to get the actual shape that you're looking for. So there's a little bit of process even after the thing is poured to kind of make sure that you're getting the shape that you want and the finish that you want. And the next slide is going to show a short video on kind of illustrating all of that.
First of all, on a clean floor, we will set the inverted drag box. Then we will place the pattern inside the box and pour the sand into the box. After that, sand is ramped and leveled off. The packed drag box is then turned over and core box is placed over it. After that, second half of the pattern is placed exactly over the first half of pattern. Then the sand is filled and ramped tightly. Now two boxes are opened and pattern is removed with the help of screws. Boxes are again put back into position and clamped with rivets to prevent upper box floating. Gates and spruces are formed to pour the metal. Now the molten metal is poured into the mold. Then it is allowed to cool down for some time. After cooling, the final cast is taken out.
So just again illustrating kind of what that casting process looks like. All of that is incredibly manual in terms of the labor that's involved. Again, for when you guys are looking at site furnishings, again, casting can create some very unique and very beautiful shapes, but typically it will also increase the cost. So if you're looking at, from a standpoint of how do I keep costs down in some cases, or, if you start with something and you're having to, reduce costs and reduce budgets, things like that, that's an area potentially for you to look at is moving away from casted pieces to reduce some costs. So outside of casting, then we have this idea of forming. So forming is often also called metalworking, but it's the process of fashioning metal parts and objects through mechanical deformation. The big call out here is that the mass of the product or the mass of the material is going to remain unchanged. So unlike with additive manufacturing, subtractive manufacturing, or casting, you are either adding or removing material and changing the final mass of whatever it is that you're trying to create. This is just physically changing the shape of whatever it is that you're working with. So in the trash receptacle world of site furnishings, you often see this type of process used. That's what this picture is dictating here. So you start with a piece of a disc of sheet metal, and it spins along this giant axis right here incredibly quickly. And then you use a variety of tools to shape these into like trash receptacle tops and lids and those sort of things. It's called spinnings. Is the term that's used for these types of tops. So that's an example of metal forming in the site furnishings world, is those spinning tops. Again, you're not changing the mass, you're just changing the shape of whatever it is that the product is.
Got a question here, David,
Yep.
from Joseph, asking if forming and forging is the same thing.
Very good question. Forging is slightly different, and that's a good question. So forging is really the bringing together of two separate pieces of metal. Typically, it's like metals that are used. So if you're trying to bring steel and steel together, you're heating them up and you are fusing them together to create one piece. So it's a little bit different than the welding process. That's often the question that I receive, is how is welding and forging a little bit different? But forging is permanently attaching two pieces of like material together so that they become one and they will never be separated. Welding, which we'll get into in a few slides, is slightly different. You're actually introducing another material into that process, which is how it kind of differentiates from forging and welding. But yes, so forming and forging, very different. So forging, you're adding mass and you're heating it up. Forming, again, not mass changing, but you are changing the shape.
Awesome, thank you.
Sure. So in this idea, then transformative manufacturing, you got a few different things that you could be doing off here in the picture here. This is an example of rolling. So the material is passed through a pair of rollers, which is exactly what it's doing. So this is a piece of tube steel that's being turned into just a pretty standard, circle kind of bike rack looking shape. Extrusion is where material is pushed through an orifice. So think of like a cookie cutter shape, and you're trying to push the material through that shape. It's a similar type process is what extrusion is. Die forming is the reverse of that. So you're actually stamping something down to create a shape. So think of a giant machine, and you've got a shape that you're trying to create. You're stamping something down on top of it, and now it's permanently changing that. So forging, this is exactly what we were talking about before. But the material is basically shaped and changed through compressive forces. So you're actually adding different things together, creating different pieces. You're changing the material around, by hammering it or whatever the case is. If anybody watches the show Forged in Fire, that's guilty pleasure of mine. But so that's an example of forging. If you're bringing materials together, that would be forging, or if you're hammering them out into various different shapes, that could be an example as well. And then indenting. So this is where you're taking a tool and you're actually pressing it into the piece, but you're not actually removing material. So think of embossing. So if you emboss a piece of metal, that would be an example of an indenting method. So continuing on in the transformative realm, we have this idea of joining then. So welding is the most common piece of joining. There are essentially two different ways that you could join pieces together. The first is really welding. Again, you're taking two pieces, you're joining them together using a weld. The other one is you could use a mechanical method, which is you're basically taking bolts and hardware and screwing things together or bolting things together, riveting things together, whatever the case is. So that's a mechanical method for joining. Welding is a method where you're actually joining the two pieces together through heat and that sort of thing. So welding is exactly that. You're melting the base material, you're adding a filler material. So that's, again, slightly different there. It creates that weld pool. You're adding a second material into this outside of the two pieces that you're trying to join together. This slide really gives you a good understanding of what that welding process kind of looks like. So off here on the right, you've got one piece of material. Off here on the left, you've got another piece of material. Again, typically they are like materials that you're trying to weld together. So this is a piece of steel. This is a piece of steel. And then you're trying to join them together so that they remain attached. And so that's the weld. So in welding, there's some common types of welding. We'll go over two on the next slide. So this is referring to MIG welding. We'll look at what that is. But so MIG welding is you're creating this little space right here. And this is your weld pool. And you're actually feeding a wire of additional material, additional types of metal through, heating that metal up and heating the base metal up. And that's what's creating this weld pool. So if you see those kind of raised surfaces where you typically see weld points, that's a weld pool. And it's the introduction of a second type of metal to join the two other pieces of metal together. So as referenced, there are two different methods that are typically used in the site furnishings realm. We have what's called MIG welding. It's the real name is gas metal arc welding. And then the other one is TIG welding, which is gas tungsten arc welding. So really what this is talking about is it's using a gas as a heat source. It's creating an arc, which is the actual heat that's being used. So gas is the fuel, arc is the actual heat that's being created. And then metal and or tungsten, the TIG welding is a more specific type of metal that's being used. Whereas MIG welding is just using any type of metal. So there's a few different types of metals that can be used in MIG welding, but it's less specific. So MIG welding, metal inert gas, is what MIG stands for, but you're feeding that wire through the gun, as we saw in the previous slide. That wire is some type of a metal. That metal is being heated up and used to kind of join two pieces together. TIG welding is more specific. Again, it's using tungsten as its its source or as its additional material that's being put in. This is a lot more complicated. It's a lot more challenging, and it requires additional certification to be a TIG welder versus a MIG welder. So you see a lot of MIG welding in the site furnishings world just because it's a little bit more common. It's a little bit easier to do. It's a little faster to do. So it's a little bit less expensive to use MIG welding versus TIG welding. Advantages, disadvantages to both. TIG welding doesn't typically give you the burn marks like MIG welding does. So sometimes if you have really, really aggressive welding, you can actually see burn marks poke through even after it's been coated. So to avoid that in some cases, if you have pieces that are showing very visibly, you would try and use a TIG weld in that situation. Question 6, again, talking about the two different types of welding here. So we have the MIG weld and TIG weld, and really just what are the common differences. So metal inert gas versus tungsten inert gas.
Before we jump into this one, David, I thought it would be kind of good to kind of cap off that section of manufacturing methods with just kind of, asking a couple of questions. How do you find that these different manufacturing methods using the additive, subtractive, and transformative examples kind of impact the rate at which manufacturers can actually produce a unit? Is there a big difference there?
Yeah, absolutely. That's a great question. So specifically as it relates to the additive and subtractive manufacturing, you would think by seeing that previous slide where you had the diagram of the additive and subtractive and waste at the end and not waste at the end versus from subtractive versus additive, that you would say, well, why don't we just do 3D printing for everything? The biggest thing in that realm is that 3D printing is actually a relatively slow process. And it's also very, very expensive to get. Again, if we're looking at from the site furnishings realm, it's very, very expensive to have 3D printers big enough to be able to produce site furnishings. They would be many, many, many hundreds of thousands, if not into the millions of dollars for a 3D printer that could print something that size. It also is a much slower process than subtractive manufacturing. So I would say most, if not almost every single site furnishings company is going to be using subtractive methods. There might be small instances of 3D printing or additive manufacturing methods being used. They're usually smaller parts. They might be prototypes, things of that realm where you could kind of do some different things with additive, but subtractive is predominantly what you're going to see in the site furnishings world.
Okay, awesome. And I guess, do you have an example of a product type in the site furnishings realm that might actually benefit from the casting method or transformative method over the others? Or is this maybe more applicable to components like a frame, compared to slats or something like that?
Sure. No. Yeah. Good question as well. So, really, the two pieces as it relates to kind of the transformative versus the casting type stuff is when you're casting. Again, as I described, it's a little bit of a manual process to do that. The major benefit to a casted part is that you can often create things with a cast that you would not normally be able to create, or it would be extremely challenging to create using forming type methods or rolling methods, whatever the case is. So casting, it allows you to create different things a little easier than using traditional transformative methods. Now, again, casting can be more expensive, but if you're trying to achieve a certain shape and there's not another way to do it, that's your best option. It's great. They can turn out some very, very beautiful things. From a costing standpoint, usually if you can fabricate parts 100% internally using additive, subtractive, and transformative methods, and not using casted methods, you're going to be a little bit less expensive. It's labor and materials is a lot cheaper using those types of methods than using a casted method. So again, add pluses and minuses to both. Casting can create some very, very unique shapes. It's unique in terms of the finished products that you can actually achieve. Trade-off is a little bit of cost, extra labor there, and then the fabricated methods of 100% internal. Those can be a little bit less expensive, but you might also be a little bit more limited with what you can create.
Awesome. Yeah, thank you. We'll keep going.
Awesome. Good questions. All right, so moving into kind of our second section here of this concept of lean manufacturing. So what is lean manufacturing and how does it really tie back to sustainability? So sustainability is, obviously a very big buzzword in the industry, and oftentimes it's thrown out there without a lot of context behind how are you actually doing sustainable methods. So lean is an example of how you can actually be sustainable from a manufacturing standpoint. So I thought it was good to kind of look at, so from a lean manufacturing, this is also question 7 here. But lean manufacturing is a systematic method for reducing what's called waste. So this system, this idea of lean manufacturing was pioneered by Toyota, the car company in Japan, after World War II. So after World War II, a lot of the countries that are not the US, their infrastructure was, bombed away and they had to rebuild everything. So out of necessity, in order to keep up with the rest of the world, Toyota came up with this lean manufacturing method to basically say, all right, we need to do as much as we can with less and be better than everybody else. So they developed this process of, again, lean manufacturing. And it's talking about waste minimalization. So waste in Japanese, Muda. It's a manufacturing philosophy. It's not, this quote down here is a good one, but I'll get to that. So it's a manufacturing philosophy of reducing Muda or waste, which waste creates what's called overburden, Mura, and then the waste, as you're removing those wastes from those processes, you're achieving this Mura. So this quote is a really, really good one because it's very important to the lean process. But lean manufacturing is not a collection of best practices from which manufacturers can pick and choose from. It's a production philosophy, it's a way from conceptualizing the manufacturing process from raw materials to finished goods and from design concept to customer satisfaction. Lean is a different way of thinking about manufacturing. So this first part here, lean is not a collection of best practices is the call out. And I believe that's exactly what question 7 is it is not a collection of best practices. So important distinction there. It's not a bunch of people saying, oh, I like that, I'm going to try that. That's not it. It's like a cultural shift of an entire organization to kind of go through this process. So there are 3 major pillars, if you will, inside lean. So the lean principles are this, but really what you need to do is you need to define what value is. And that's how you can then in turn define what waste is. So value in the terms of lean is anything that a customer is willing to pay for. If a customer is not willing to pay for it, then there is no value to it. So that's an important distinction of how you start this whole process. Once you look at your processes, your manufacturing, your business through that lens of if a customer is not willing to pay for it, it is waste, and I need to figure out a way to eliminate this waste. Now, there are some non-value added things that are required to run a business. The example I always give is, large businesses, they need accounting teams to run financials and, keep track of cash flows and those sort of things. That is not something that a customer is willing to pay for. They're not going to pay for you to have very accurate books and very accurate, accounting processes. It is required, though, to run a business. So non-value add, but required. So understanding that value is going to be the very, very first step in this process. So once you understand and define what your value is, you're going to actually map where value occurs in your organization. You're going to create the flow of how that runs through your organization, establish a pull method, and then pursuit of perfection. So pursuit of perfection is you are always looking to get better. You are always looking to eliminate waste. Even if you just eliminated this waste, there's probably a way you could eliminate even more waste from that same exact process that you just eliminated. So, if you take a process that normally takes you an hour and you just said, hey, I eliminated some waste and now it only takes me 30 minutes, great. How can you take that 30-minute process now and do it in 20 minutes and then in turn do it in 15 minutes? So that's the pursuit of perfection there. The other one I typically get a lot of questions on is what is establishing a pull method? So establishing a pull means that you are pulling something through a manufacturing environment as opposed to pushing something through a manufacturing environment. So the examples there are, let's say you are, trying to produce a bench in the site furnishings world, okay? If a customer places an order for a bench and you produce that bench because the customer has placed the order, that is a pull method, meaning you are only pulling that product and those processes through the system because a customer has requested it. If a customer did not place an order and a customer did not request it, but you are pushing a product through the manufacturing facility because you think eventually somebody might buy that bench, that is a push method. So that's an important distinction as well. Lean is trying to establish this pull method where it's an on-time system where it's only doing things when it is actually needed and required. So the lead into that is defining what are the actual wastes in a lean environment. So there are actually 8 deadly wastes. The 8th is this one up here, which is the potential of people. So the question 8 here is that the acronym for all of the wastes is downtime. So that's the answer. But the 8 deadly wastes are defects, overproduction, non-utilized talent, that's the people component, waiting, transportation, inventory, motion, and extra processing. So all of those are examples of when you experience waste. And inventory, as we kind of or I alluded to in the previous versus the push and pull method, if you were to push a bunch of benches through your process, but nobody has actually ordered them or bought them yet, that means that you're creating inventory and you have to store it somewhere. So that means you have to have a bigger warehouse to actually store things. Once they're actually produced, you actually need to transport them to wherever they're going to be stored. Once somebody actually buys them, then you need to actually go get them and do some motion to go get it and then package it and then transportation again. So there's a lot of instances of where that could be or where that could be creating a lot of waste in your environment. So if you eliminate some of those things, you're going to have a much more efficient and lean organization. So the last kind of pillar of the lean manufacturing philosophy is this idea of 5S. So it stands for sort, stabilize, shine, standardize, and sustain. And really what this is doing is this is helping you to identify where waste is. So if you're sorting things, if you're stabilizing things, if you're shining, which is really the idea of cleaning, this will allow you, this part up here will allow you to see, hey, if this box has a bunch of stuff in it and it takes me 10 seconds to go find exactly what I'm looking for, how do I maybe make that a little bit better and say, maybe it shouldn't take me 10 seconds, maybe it should take me 5 seconds. So there's an opportunity to improve. Stabilize, so hey, everything's got its place, I know exactly where it is. Shine, cleaning an environment, keeping it clean, is a function of the lean process. So you'd be surprised at how many manufacturing facilities get pretty dirty. It's a dirty process, so keeping it clean is pretty important. Standards are vitally important. So you want to make sure that if you're building a bench, you're building it the same way every single time. So creating a standard and following that standard and making it bulletproof that anybody could pick up this standard and follow it is the goal of lean. And then you have to sustain that. So if you do this all once, and then that's great, but nobody actually follows it, that's not going to be helpful. So you need to, the last part is definitely important of you need to sustain it. You need to keep going, and you need to keep doing this over and over and over and over and over again. All right, this thus concludes our lean section, and we'll move kind of into our last section here, which again is designed to really kind of be a presentation version of a virtual tour as much as we can get. So we've got a bunch of videos in here. We should be able to kind of conclude here at 1 Central Time to kind of get everybody on with the rest of their day. But this is going to load. So just an example of what a metal shop would look like in the site furnishings realm, all the various, pieces of equipment, people that are involved, how big that facility can actually be to actually create some different things. So really the concept here is we're starting with some type of a material. So in this case, if we're trying to create this type of bench here, we're starting with aluminum. There are casted pieces on this ends here to create this unique shape here. There are also steel components, so there's sheet pieces of metal here. You're laser cutting, you're forming things, you're welding things, you're machining things to get your hardware to physically join those together. You're adding in coatings, so there's a cleaning process in there. There's primers that are involved. There's a powder coating process that's involved. And then once you can combine all of those things together, you can actually create your finished product in the end. So again, kind of revisiting our casting piece here. So we've got our sand casts. We're creating our shape. We're pouring our metal in. And then as referenced, once you actually create that and everything cools down, there's a bunch of extra stuff that shouldn't be there that's going to be attached to the casting when you break off all the sand. So all of that needs to be refined away. So all of this stuff needs to be cut off and sanded and finished to kind of get a casted piece, which is something like this in the end. So there is, again, not only the upfront piece of actually creating the molds, creating the sand cast, pouring the shape, allowing it to cool, but then you actually have the finishing and the refining part afterwards, and then you actually have your casted piece. So starting with the casting, again, not all the time, but if you are starting with the casting, casting is also typically done not in the same facility as you are doing the rest of your site furnishings building. So it's done in a forging facility. It's a very specific type of process that's done. You want to actually kind of separate those two. You don't want to have this, a forging or a casting environment in the same place that you're doing transformative manufacturing. So you separate those two. It's very, very common. There aren't very many people that have both, at least in the same place. Usually it's an outsourced product. Somebody cast this for you, and then you bring it in, and then you do your thing in terms of manipulating and coating and whatever it is that you're going to do to it. But so casting could be the first start. If you're not doing that, then you could be starting with subtractive methods. So in this case, we're talking about a laser cutter. So here's an example of a laser cutter in action. It's kind of cutting out some, small parts of some kind. So the laser in the picture here is creating, some type of a shape. This is for a bench, but so it's creating out and cutting out a shape here to create, a bench. So laser cutters are incredibly quick, as you can see from the video here. They're very, very fast to cut. They can cut anywheres from, very, very thin gauge metal all the way up to, maybe 3/4 of an inch or an inch in some cases. They usually don't go higher than that, just because laser has a hard time penetrating very, very thick material. So usually you use a different type of cutting type of machine to go thicker than, you know, an inch of material. It's an automatic CNC, meaning that it's going to do it on its own. You set a computer program and it does its thing. And so that's what you're seeing there.
Real quick, David,
Yes.
how complex can you get on the laser cutting side of things? I mean, the image on the left on the previous slide was one of the, I think, more intricate patterns that you guys have. But I mean, realistically, you know, how complex can you get?
Um, so yeah, you can get pretty complex in terms of the actual cuts. Really, the only limitation to cutting of with a laser cutter is ensuring that whatever it is that you're cutting is not like a circle within a circle kind of thing. So you know, it is a piece where it needs structural integrity. So you can't have a floating circle inside of a, you know, a hole because there's nothing attaching to it. So really, the sky is the limit in terms of what you can create. You just need to make sure that, again, you've got attachment points, and there's always a point where it's connecting back to really the structural elements of the entire piece of, in this case, sheet metal. But really anything.
And is there a I guess a figure or a threshold that you guys will kind of keep in mind when you're working with patterns that maybe have less contact points, so that, you know, that particular surface isn't actually, you know, what's the word I'm looking for, kind of going out of shape when put under pressure, say if it's like a bench seat or a tabletop or something like that?
Sure. Yeah. Also good question. So there's a few variables that would be involved with kind of looking at what you're describing. So the first would be the complexity of the pattern. So that's going to be your very, very first. The complexity of the pattern is going to determine where the structural elements are. So again, if you're talking about creating a bench, for instance, you know, somebody's going to have to sit on that. So if you cut away 95% of the material and you're only left with 5% of the material, you know, that's a very extreme example, but there's probably not enough structural integrity if you're cutting away that much. So there's not really a perfect ratio to say like, oh, you can only cut away 50% and that's the max you can go. The next variable that you would have to consider is based on the amount of material that you are removing. What is the gauge of metal that you're using? So if you're using a relatively thin gauge in the site furnishings world of maybe like 14 or 16 gauge, that's not going to provide you a lot of structural integrity. Now, if you're going down to maybe 11, 10, 9, 8 gauge metal, that's much, much thicker, and therefore it's going to provide more stability. So again, not maybe a perfect answer, but there are a few variables that are required to kind of look at as you are cutting away and using a laser cutter. I would say the first is, what is the percentage that you're trying to cut away from the actual base piece? And then within that, are there, you know, channels or sections, you know, along the sides or maybe down the center where you can hide structural elements that you wouldn't necessarily even notice? Maybe further down is, if you are cutting away a lot of pattern, can you weld in or add in additional support elements at a later process using transformative methods to provide rigidity to make sure that there's enough structure there. And then all of this, you know, typically is going to be tested. So if you are creating a shape, a bench, there are some guidelines and standards that are put in place for, hey, if you're creating a bench and it's going into a public realm, it needs to adhere to certain guidelines and certain standards for holding enough weight. That can range a little bit. Certain manufacturers will do, you know, different weight requirements and that sort of thing. So it's a little bit dependent. There is a base standard, but each manufacturer will kind of either go above that or not. So I hope, does that kind of answer your question?
Yeah, that was really great. Thank you.
Sure.
Yeah, happy to keep on going.
Perfect. Okay, so what we're looking at there in the what we're looking at there is the sanding process. So immediately coming out of some type of a subtractive manufacturing method, you're going to have little either tabs or little deflections, whatever the case is. It's not going to be perfect. So you need to sand all that down, especially since it's going into a customer space of some kind. You want to make sure there are no sharp edges, things like that. So most of these things, once they're cut, wherever the cutting actually occurred, is going to be sanded down. So that way, again, you're removing all of those different pieces. Our next piece, we're working into kind of our forming or metalworking type pieces. So a common thing in the site furnishings realm is this idea of a brake press. So it's a giant hydraulic machine that's used to physically change the shape. So in the picture here, you can see he's trying to create and bend a bench seat pan into a shape. So the video up here on the right is a really, really good illustration of what a brake press can do. So yeah, so the machine is using hydraulics to press down into the metal, again, permanently change the shape of that piece of metal. And now it's, again, whatever it is that you're trying to create. In the picture here on in the middle, they're trying to create a bench shape. So you could use that brake press method to create that. So in that they're just creating a few small parts, but again, using that brake press to change the physical shape. So question 9, so we're talking about welding here, but welding is typically required in site furnishings. If you're metal forming a few different pieces, you got this piece that's cut over here, this piece that's bent and welded over here. You've got to combine those in some cases to create the types of things that you're looking to create. So the question here is, what are some advantages and disadvantages of welding? And the major disadvantage to welding as it relates to site furnishings is it makes that weld pool that we talked about earlier, makes it more challenging for a coating. So a lot of times a powder coating is what's used. So it makes it more challenging for powder to stick to a weld point. And it's not because it's a different material or a different metal that's being used. It's because it's not a flat surface. So weld point, the better you can make your welds, the cleaner you can make your welds, the better you can get an adhesion of whatever it is that the coating that you're using to try and protect it down the line. So usually you see failure of site furnishings or rusting or pulling away, that sort of thing, from weld points. And that's why. Is because it's more challenging to coat a piece at weld points. So something to consider when you guys are reviewing site furnishings is are there a lot of welds being used to kind of create the pieces? Again, they're typically, it's a necessary evil to create welds and use welds in site furnishings, but if you can limit those, that obviously would be helpful, for the longevity of your site furnishings on your site. So I mentioned the other piece, the other way that you could join things together is using mechanical methods. So in this case, you're talking about maybe bolting things together, using hardware of some kind to join things together in the end. So those are typically like assembly things that are done once everything is done and produced. So just showing a little bit of, kind of what welding would actually look like. So once you've gone through your metal shop, you've done all your various different things in metal, you have to clean it. So it's a very dirty process. You're using, there's a lot of oils involved. There's a lot of different machinery involved, a lot of people touching it. So there's oils from people and hands and A lot of times you're using gloves and that sort of thing, but there's a lot of different foreign things that are introduced in the metal process. So you have to clean all that. You need a very, very clean surface before you get into the coating process. So there's a variety of different ways the cleaning process can be done, but oftentimes it's this type of process where it's an alkaline rinse. So it's like a metal type rinse that's being used to clean all of that stuff off. So metal shavings, oils, dirts, all that stuff is being cleaned off prior to the very, very next stage, which would be your coating process. So prior to the very, very first step of coating, oftentimes is using a primer. So it's not required by any means, but it does give you a much stronger adhesion of whatever is the coating that you're using. So if you're using a powder coat, you're often using a dry primer. There are also liquid primers, depending on if you're using a different type of coating. It's an epoxy primer is usually what's done to kind of achieve a better adhesion of your coating. And so the goal of primer is to increase the adhesion, make it more of a chemical bond as opposed to just a physical coating, which is going to give you, again, longer longevity of your pieces out in the field, as well as increased durability. So a quick review on just powder coating. So powder coating is a powder. It's a polyester powder that's applied electrostatically. It's a fancy way of saying that it's applied using positive and negative charges. So the powder itself is stored at a neutral charge in bags. And then the grounded line, the manufacturing line, everything is typically hung from a conveyor belt type system. That whole line needs to be grounded, which represents the negative charge. And then the powder gun here, which you can see in the picture, has a special electrode at the end, which picks up a positive charge as the powder is being shot out. So the powder then picks up a positive charge, it interacts with the negative grounded line part, and that creates the initial attraction. Once that attraction is, it's stuck, it goes into heating, an oven to heat and cure, and that's what you're familiar with when you see powder coating out in the field, is that heated, cured powder coating type finish. In terms of thickness, powder coating is very, very, very thin. So the actual thickness of powder coating is measured on the scale of mils, which is about 1,000th smaller than a millimeter. So very, very thin. So it's about 6 to 10 mils in thickness, or if you throw that into the imperial system, which is inches, you have 0.0006 inches in thickness. So incredibly thin is what powder coating is. It's one of the disadvantages of powder coating is that it is so thin. As long as the powder is intact, it's great, but it is easily compromised due to nicking and whatever the case is. Bake temperature plus or minus 350 degrees for that final cure. So just a quick touch on again, what powder coating actually looks like. We only got like 2 more slides, so bear with me. I apologize, I'm over on a few minutes. But so another method, so I mentioned, people mostly familiar with powder coating. There is another type of coating out there, which, it's called a fusion advantage. And it's really, it's a combination of another coating method technology, which is called plastisol coating, as well as powder coating. It's a combination of both. It's a coating that gives you a lot of advantages. I mentioned with powder coating, it's very, very thin. Plastisol coating allows you to have a very, very thick coating. So you're not going to have those issues of maybe nicking and, getting down to the raw metal there. But plastisol coating is a type of coating that will fade. So you don't hold colors with plastisol very well, whereas powder coating does hold color extremely well. So when you can combine the two technologies together, that gives you this fusion advantage coating, which is a little unique. You start with prime metal. Again, you dip into a plastisol vat, and then you can powder coat over top of that, which is a little unique in there. Same thing. So now you're approaching 1/4 of an inch in thickness. So again, very different from the powder coating process. Bake temperature is still going to be in that plus or minus 350 degrees for the final cure. And major advantage to this is you're eliminating disadvantages, getting a lot of advantages out of that. I did see a question pop in. What sort of powder coating is used in high-end furniture from places like Janus Etsy, Forest Share? So, yeah, I'm not necessarily familiar exactly with what their powder coating is, but it's still going to be a polyester powder. There are levels and grades of powder that are used in order to create used powder coating. So it could be a high grade powder coating. But most of the site furnishings companies, they're all buying from the same powder coating suppliers. There are, a handful that supply pretty much all the site furnishings companies. So it's the same thing. It's a polyester powder. It's applied electrostatically, the same process. Which company they're using for their powder coating supplier, I'm not sure. But it's going to be pretty much the same process. There's no difference. The difference is probably going to be, what's the base material that's being used, which I'm familiar with that chair. I think it's a casted aluminum chair. So you're powder coating over top of casted aluminum in that case. So you've got your coatings, and really you want to make sure, we talked about it in the lean process, but you want to make sure that you're creating something consistent all the time. So you have a quality control piece. This is going to be very common in any manufacturing facility, but especially if you look at it from a lean perspective, you want to try and practice quality at the source. And what that means is you don't want to cut something out on a laser cutter, find out that there's an issue when you're assembling it and getting ready to ship it. You've gone through all those processes, you've welded it, you've cleaned it, you've coated it, you've done all this different things. You might have even started packaging it, and now you've noticed that there's an issue. That is a lot of waste. So if you can catch mistakes immediately when they happen, it eliminates a lot of waste. So quality at the source is a pretty important piece. It's the big call out. There's no nerds with clipboards, walking around in white lab coats, kind of saying, hey, this is good, this is not. This is practiced by the actual people that are making the products. So quality at the source is a pretty important piece to ensure, consistent quality coming out of the facility. Last slide and last question. So manufacturing processes, you've got assembly and shipping, which are, necessary in the site furnishings world. This is something that you are going to want to understand based on what site furnishings companies you're working with. Do things require assembly? Yes or no? Sometimes yes, sometimes no. Pluses and minuses to both. If it doesn't require assembly, it means it basically comes off the truck, comes off the pallet, and you put it there and you're good to go. The downside to that is if it is shipping fully assembled, like you see here, this is a 6 foot long bench, shipping fully assembled, that's a lot more expensive to ship when it's fully assembled. So you can save a lot on freight if you assemble some things on site. There's a fine balance between a lot of assembly and not a lot of assembly, as well as saving money on freight and not saving money on freight. But that's something that you want to understand is assembly required? How are things shipped? Are they shipped in boxes? Are they shrink wrapped? Are they palletized? How do they come? Do they need trucks to unload it? Forklifts, that sort of thing on site. Oftentimes, site furnishings company, because of the uniqueness of products, you get a 6 foot bench that has a back and then a 6 foot bench that it doesn't have a back. So that's a slightly different packaging method, even though it's the same collection of a bench. And then if you have a site furnishing that's a trash receptacle that's in that same collection, now it's a completely different thing. So there's a lot of times specialized packaging equipment and machinery that are used in site furnishing environments to create on-demand packaging that is unique to every single product. So you're creating unique boxes for every single one, putting them on pallets, that sort of thing. So question 10 is really around understanding the assembly and shipping process and what are the advantages of pre-assembling versus assembling on site. And that's it. I apologize, I went over on my time a little bit. But any questions?
That's no worries at all, David. We always can go over time to make sure we finish things off well. We don't actually have any other questions at the moment, but guys, as always, absolutely encourage you to reach out to David or Anova directly. His contact info is on the slide, as you can see. If you end up thinking about anything after we sign off today, today's presentation has been really fantastic, a really different perspective on, I think, a section of the wider design industry that we probably don't get, as designers, don't get a look at or don't look at as much. So I definitely learned some new things about the manufacturing world, different design philosophies, methods. So I hope everyone else was able to take something away from today's session as well. We are, of course, posting this webinar up on our website later today as we record all of our sessions, where you can rewatch, check in on a couple of spots if you missed anything, or pass it on to anyone else who wasn't actually able to make it to today's session. But just in finishing up, I'd like to thank David for his time in presenting today and organizing this presentation. We really appreciate our guests' efforts in putting these presentations together, and of course looking forward to providing more opportunities to connect our designer community with manufacturers and other guest speakers in future. David, did you just want to make note about the QR code and what that was for?
Yeah, absolutely. So I've got the QR code on the screen. As mentioned at the beginning, there is a post quiz with all the 10 questions there. So this QR code will take you directly to that quiz. This is new. I've never actually done this before, so hopefully it works. You should be able to just scan it if you open up your camera on your cell phone. It should automatically come up with a little box to check the QR code. If for some reason that doesn't work, please email me direct. My contact information is down here, david.t@anovafurnishings.com. I can send it off to you directly. But once you complete that quiz, it will automatically take you to a finished screen. And that I would print screen that, and that is your certificate of completion. So use that as your certificate of completion if you require that for self-reporting to state and local agencies. But any issues, please let me know. Give me an email. Happy to do that.
Yeah, fantastic. So yeah, once again, thanks everyone for attending and being here today, and have a great rest of your day and weekend. Thanks again.
Thanks all.